All right. Thank you. So I want to thank you all for coming today, and I appreciate you listening to this presentation. We had some great conversations today with a lot of different people. And what I wanted to leave you with was just a little bit of a story, which is all about what your definition of done is. We hear about this all the time. You're at the dinner table, and somebody asks you, your waitress, your waiter, your server, are you done? Should I take away your plate? How do they know when you're done? And often they come to your table when you're chewing your food and you've got your mouth full and you can't actually answer that question. So, one of the things I always like to think about here is okay, well, maybe I'm done. Maybe I want that last piece of cake. Maybe I want that last bit of a drink. Maybe I want what's on my plate here. But how do you know when you're done? Now, you go back into the kitchen if you're the server and you think, well, when's that person going to be done? How do I know when to come back out? It could be awkward. Should I come out while they're finishing? Should I wait till they're having a conversation? So if you ever worked in the food service, you know this can be complicated to know when they're actually done. So the best way to do it is to ask. So at work, when you're writing software, how do you know when you're done? Like your boss asks you, are you done with that project? Your neighbor asks you in your cube next to you, are you done with that project? Are you done deploying this? Are you done writing the code? Are you done fixing it? What exactly does done mean in software development? That's one of the keys that I want to talk about today and get you to think more about what is the definition of done? Does done mean your code is committed? Does it mean your tests work? Maybe for you, it means it's Friday. Hey, it's Friday now, right? And we're done. What exactly is done to you? And I think you'll find if you ask different people, done doesn't always mean the same thing. What it means to you may not mean what it means to me or to the person next to you. So let's think about this. If we're going to have some kind of a Friday night deployment that we're going to be working on, it kind of feels like this sometimes, doesn't it? We're just living dangerously. We're sitting up there and just worrying about nothing. It's got the weekend coming in front of us. Do we deploy on Fridays? We tend to try not to, right? But if we don't, are we done? I'm not quite sure. So, my name is John Papa, and I want to talk to you today about the 7 Ds of development and DevOps. And by the end of this conversation, hopefully you'll understand and have a better idea of how to think about what your definition of done is to you. So, today, maybe what you do is you write some code. That's the piece that a lot of developers like to do. I enjoy writing code. It's just a lot of fun to put things together, and I really get done with my code pretty easily. So when I'm done writing code, I feel like, yeah, I'm done. But I also have to ship it, don't I? So I write my code, I ship it, and I just walk out the door, or maybe I pray that everything just works. That's kind of how I like to think about things sometimes, but that's probably not a great idea for consistency and having really successful software. So, how do we ensure that the quality that we have in our code makes it so it's maintainable and everybody can use our code? We have different people on our teams who have to pick up the code and work with it and then make changes later. You know, the number one reason why projects get restarted from scratch is because the previous team couldn't figure out or took too long to figure out how to actually maintain and modify the code that was there, or the code just was unmaintainable. So the 7 Ds can help with all of this. And it really gets down to how we think about the one message. What does done mean to you? So with done, do we want to make sure that we develop and release our code? Absolutely. We have to put it together, that's the development side, and release it. Do we need to make sure that we deploy it all the proper environments? Absolutely. Should we communicate it? Well, let's think about this. If you don't tell people that the code is coming, that the new release is coming, and what's in it in a change log, will they know what to expect or how to make it work? For example, a lot of different software devices out there with apps. If you've got an iPhone or a Google device with Android, you see in the stores, they show you change logs of what comes out for every new version. That's communication. And they provide a way for you to engage with them as well. That's the feedback channel. Part of the whole process should be that if there's a problem or a question, there should be a way to interact and engage with your users. So, okay, let's just jump right into the 7 Ds. So, to figure out how we get to done and how we get all these things to make sure that our software development works through the cycle. The first D in the 7 Ds is design. This is the piece where we want to make sure that we have designed out our code and everything just works as expected. So, what is the user experience? This is where you sit down and you talk with your users, or you use Zoom or Teams over the internet to figure out what exactly is going to be the experience. What do my business stakeholders want? What about the developer tools? You have to figure out your developer experience. What are we going to be creating? How are we going to split up our teams? How are we going to work with source code control? What is the API that we're going to be working with to get our data? And is this one feature, two features? How do we split up the team? How do we split up the source code? Make sure we should really figure out what this whole architecture looks like. This is something most of us are very familiar with, and we understand the design aspects. A lot of us do the design up front, and then we re-examine things as we go along. This is where you work with either waterfall or agile, or you can mix the two. Either way, there has to be some kind of design element in what we produce. So the first D is design. I'm pretty sure you're all familiar with that step. Now, this next step, I'm very sure you're familiar with, and that's develop. The second D is you develop your application. And what does this mean? Sometimes you could create your API first. I recommend that you do create the API because this is the piece that's going to allow you to talk between different layers of your application. For example, if you're building a RESTful API or using serverless, you could create your API and then create your UI separately. Another way to look at this could be you could create a mock API first. So creating the API doesn't mean you have to go create the server code first. It just means you create that API. What is it going to look like when I talk between my front end and my services for my API, my endpoints? Make sure you've got the API definition created so that you can have your different teams or yourself create these pieces separately in parallel so you can actually connect them. You think about your separation of concerns as well. Where am I going to create these different parts of my application? What kind of developers do I need to work on these? Does everybody have the skills to work on those? What are the guidelines and rules that we have? Have I created readable code? What are my guidelines to make sure that when I write my code, others can read it, including myself? Did you know that we read code 10 times more often than we write code? It's true. There's been studies on this. So we want to make sure that the code we have is truly readable. Can somebody else really look at our code and make sure they can refactor it and manage it and maintain it? And what is that quality level? And it's up to you to figure out with your teams, what are the quality levels that you use? I recommend using style guides and then automating those through different tools like ESLint. So you can make sure that your code level is where you want it to be, including things like testing, which we'll get to. Okay, so now we get to the third D. So far we have design and develop. The third D is destroy. And I like this D. Destroy means that we must make sure that the thing we have is resilient, that it can stand up to what it's supposed to do. So how do you make sure? Well, you have to destroy it. Destroying it is testing. Yes. So we're going to destroy our code. We're going to make sure that the things that shouldn't happen don't happen. We all like to write our code for what we call the happy path, where everything just works naturally and the user is going to do exactly what we expect. Well, we all know after you deploy code, users don't always do what you expect. So we're going to have to make sure we test all the major pathways. We want to make sure we've got guard logic in place. So if something gets passed in improperly, where type checking won't help, that we actually check for that. For example, having an array, we expect an array to have a certain amount of values in it in a certain structure. We can test for that it's an array and it has the structure. We can't always test for how the elements and what's in that data points though. What if there are no data points? Make sure everything is in there as best you can. Always test for the unhappy path. You destroy your code. This is the key aspect. Always test for the unhappy path when people go through your code scenarios and they do things that are unexpected. As best you can, try to prevent them from happening and be proactive. And where you can't, have tests in place to make sure that it's handled well. So really, this is all about making sure you've got different kinds of tests in your application so you can destroy the code that you wrote to make sure that it truly is resilient. Think of this like the crash test dummies in cars that they use, where they crash the car into a wall with a crash test dummy to make sure the car is actually safe. That's what you're doing in this case. The car is your code. You want to make sure that the test destroys what you have so you can make sure that what comes out at the end is a functional car or a functional piece of code. I'm a big fan of end-to-end tests as well. So things like Playwright or Cypress are wonderful tools to use to destroy your code. Okay, so we've gone through designing, developing, and destroying. What's the fourth D? We've just gone through the testing aspect, but how about document? Now, this is something that gets a lot of controversy. Documentation is often one of the first things that gets left off a project. People just assume that they have the same knowledge as the person next to them, that, well, they'll just figure out how it works. Have you ever walked into a project and been given the code base and just told to go fix something, and you're trying to figure out, what am I even looking at? This is where documenting can really, really help you. Now, the controversial part of this is I'm not a huge fan, and I do not advocate and recommend having large sets of documentation, because the more piece of documentation you write is the more you have to update. And if it's not actually useful, then you're just wasting your time, either by updating content that isn't useful, or it gets stale and then it just makes it harder for someone to look at. So how do you make good, useful documentation? Answer questions like why. Why would somebody use this code? Why is it here? Your comments in your code or your documents that show how it works should answer why someone should use this. What is the purpose of this? Don't explain what the code's doing. People can read code. Explain why it's there. And how do you get started? This is one of the key things I see missing from most GitHub repos. John goes and checks his notes. Oops, I've done this myself. Create a GitHub repo, give it a great project name, share it with the world, make everybody really happy. And then everyone's like, well, how do I actually get started with it? What do I do to install it and try this out? What prerequisites do I need? How do I get that environment? Things like code spaces make this really, really nice, by the way. Create a dev container for it so someone can spin up a code space and run it right in the browser with a GitHub repo. So how do you get started? And it should be, my ideal rule of thumb is 3 steps is what I aim for. And then any step over that, I have to have a really good reason for having it still. I try to reduce as much friction as possible to getting started. And what are the dependencies? Does it depend on anything? The first key is remove as many dependencies as you can when you're designing the application. But if you didn't, what are those dependencies that we need? A README. A README is so important. And please, when you create your READMEs, we already talked about the installation steps and how to get started. Make sure it explains why someone would use this, going back to the first bullet. And one of the pieces I see everybody leave off, not everybody, but lots of people, is the change log. Have you ever seen a release from a major web framework, for example, or from some other software, where a new release comes out and you're just trying to figure out what exactly is new in this release? Or you're several releases behind and you want to know, how do I catch up? Change logs are critical for this. And now a good change log will link to GitHub issues and pull requests, but it'll also explain in summary quickly what those things actually were. So you don't have to go back and forth between 20 clicks to figure it out. Now, you could also use something like Hugo or ViewPress or Gatsby or other tools, 11T, to create your documentation. I highly recommend using one of those tools. They already set things up out of the box for you, makes it easy. You can host them up on a website if you'd like to. That's what I do for some of my open source projects. Another thing you can do is a code tour. So inside of your code, you might want to give people getting started tips right in the context of VS Code. So there's an extension called Code Tour, and I'll provide the link for you, where you can use this to actually point to specific spots and files and give instructions for people on what they have to do step by step and why the code's working the way it is. These are examples of good documentation you can use: README files, change logs, code tours. These will help you really convey the message to your users. So we just went through documentation. Now we've got 4 Ds. We've got 3 to go. The next one is demo. Ironically, most people already do this, but they don't always call it this. Have you ever created an application and you wanted to just make sure it works? And you're like, yeah, I've got tests, but I just want to create like a little shell application to try this out and to make sure it works. Some people call this a harness app, for example, or a test app. I call it a demo. And what do you do with that demo when you're done? You should keep it. You should put it in the repository with your code base. Why? Because it becomes a useful tool for other people. Well, why is that useful? It was useful for you when you created the application to see the app running in context with your code. So that demo is a fantastic way for other people to learn how to use it, to see it. Are you a reading learner or a visual learner? There's different kinds. Some people like to read a README file. Some people need to see the thing happening to really understand it. And some people need both. So by having a demo in your repository, it provides living documentation on how to use this. And it provides you a very highlighted way to look at certain features in the app. It also ties back into destroy. You can use this for your end-to-end tests that you use with Playwright or Cypress or whatever your favorite tools happen to be. So you can use that demo, and I like to put mine in a folder called demo. You put it anywhere you want in your repo, which makes it basically a fully functional mono repo. You've got your code base and a demo right in the same place. And this is a fantastic way to share the knowledge and ties back into documentation and destroying with your tests. If you look at a lot of my repos, you'll see these demos in the applications because that helps me understand how it works. And then when I go make changes, I like to run through my demo to make sure everything still works, both manually and then through end-to-end tests. So we've hit 5 of the Ds now. The demo is a great piece of this. And everything starts with D, which makes it just super nice. But what's the next D? Well, I struggled with this D. To be honest, the next D is all about how you manage your reviews, your code reviews, and make sure things look right. So the next D is the review. You've got to do the review or the review. So the review is the 6th D in our 7 Ds. And often here, what I look for is I want to avoid having a major heartache from somebody looking at my code and not knowing what's happening. One great way to do this is I like to set up a process for code reviews. Yes, there's automated tools for this. That's fantastic, but I still want people's perspectives. We still have jobs for a reason. We have our own perspectives and our own experiences, which we try to pool to look at our code to make sure we're doing the right things and avoiding big mistakes. Did you think about that when you wrote this code? That's a great reason for a review. So some of the rules I put in place, and these are just guidelines, is create small pull requests often. The smaller the pull request, the more focused the feature is, the easier it is for you to get it in, to get it tested, to get it looked at and reviewed, and get it merged. The larger the review, you might encounter something like this. Oh, John, you created this great set of code, but it's doing these 5 different things. I like 4 of them, but this one thing over here, I think we really need to fix that and change it. Well, what just happened? Now I can't merge the other 4 because the one is something I need to go back and work on. Well, if they weren't entirely interconnected, if there wasn't a way to separate them, that's one thing. But if you can separate those out into 5 pull requests, it makes life a lot easier. Work on something, get it into a pull request, get it reviewed, move on to the next. And queue these up for folks. And these pull requests should run error-free. Nothing's worse than pulling down code and it just doesn't work. Well, it doesn't work because I'm not quite done. There's another feature coming. Well, great, but do something. Put a mock interface. Put in some kind of a to be determined. Put something in the code to make it actually function. You never want to merge code that doesn't work. One of the rules I like to have is 2 people should review all aspects of the 7 Ds in a code review. 2 people who are not the author of the code. So you make a pull request and then person A makes that, and persons B and C are the ones responsible for reviewing it. And always request feedback and then sign off on these. Never just merge blindly on a Friday night right now and call it a day. Otherwise, you're just asking for trouble, right? So the review is a good piece. It's a good tool. How you set up your reviews is up to you. Use your own guidelines. You don't have to follow the ones that I've kind of laid out here. There's a lot of great blog posts and information and studies on how to do reviews. The key is make sure that they're actually happening and they're not being done by the person who wrote the code. Otherwise, you end up with a code quality measurement, something like this, where you go in, you've got good code, and people are only going, what does that mean? What does that mean? A couple times. And a really bad code review could be like, dude, what is going on over here? So our seventh D, this is probably the most important, and ironically, one of the most left off that I see next to documentation. This is deploy. I've seen lots of times where people go through the entire cycle of getting everything out the door, all 7 Ds, well, at least 6 of them. And then they finish and they go home. And everyone's like, well, did you deploy it? Well, I think so. I merged it to GitHub. What does merging it to GitHub mean it got out? Well, maybe. I don't know. Should we go test? Should we make sure it's there? How do you deploy? Let me put this a different way. If you made a great product, maybe you make something like iPhones, and you build it, and it's great. And Apple just had an iPhone event, right? A couple months ago. They go out and they share it with everybody. Here's the great new phone that's out there. Wonderful. What if they pent up all this demand for getting it, but they didn't actually put it in their Apple store? They didn't put it in the Apple store. Nobody could buy it. Nobody could buy it. Apple wouldn't make money. Apple couldn't make money. They wouldn't exist. So deploying it's kind of a key piece. If we make code and we get through all the 7 Ds and we don't actually ship it, the deploy part, nobody can use it. It's not real till it's deployed. So what does deploying mean? Well, of course, we've got things like CI/CD. We want to make sure we're using some kind of a continuous integration, continuous deployment or delivery model. It's not real unless it gets to our final server. Is that your staging server, your production server, what server you have? You have different environments, and that's also a key. Make sure that you've got your environment set up and established. Version strategy is also very important. Do you update your version following some kind of a convention like semver? So semantic versioning is great because it shows you've got a major, a minor, and a patch version. It communicates what is happening in this version. Was there major upheaval? Is everything incompatible with before? It's just start from scratch. That's major. Is it a minor where everything pretty much works the same except there's some new things introduced in this application that might have implications for the users? Or is it a patch where you shouldn't notice any changes here, we just fix some bugs under the covers? Having semver or any kind of version strategy is really important. Build numbers are also a great way to communicate, so when things do go wrong, you can actually examine and make sure that your deployments got out there. Here's a key one. Can people get to it? How do you make sure that your deployment worked? One way is to call a user and ask them if they can use the application now and they see the new version. Another way is to automate these and have automated ping tests for your application where you can go check and make sure through automation that the application is working. You want to communicate the release. What if nobody told you the code was out? There's a new version. Well, that would be difficult because you wouldn't know. You might have unexpected dissatisfaction with your users. You might even have a worse problem where major issues happen. So communication is important. And with communication comes feedback channels. We don't just write code, throw it over the wall, and then go home for the weekend. We have to make sure that we communicate the release and we provide some feedback channels, and then we're active on those channels so people can respond and tell us what's going on, and we can give them tools to communicate with us. Because deploying, remember, it's not real unless you actually deploy. So let's do a quick review of the 7 Ds and then talk about some ways that you can implement these yourselves. There are 7 Ds, of course: design, develop, destroy, document, demo, to review, and deploy. With those 7 Ds, first we design. Again, it's the experience. How do you split features? What's your API look like? It's basically your planning aspect for your application. And you can do design not just at the beginning of a flow, but at any point. You can revisit the design throughout your application to make sure that you're giving the best experience. Developing. You want to make sure that you make your code readable. Readable code's a big, big aspect. And you want to make sure that the code is readable by you and by others. And if you don't think this is real, go back and look at some code that you wrote last week. See how long it takes you to understand what that code's doing. I've written code sometimes where the next day I couldn't figure out what I was thinking about before. So readable code is really huge. And if this is just me looking at my code, imagine someone else looking at it who doesn't have the context of what I was doing. when I created that code. This gives you the confidence in the quality of your code. Then we get to destroy. Test those unhappy paths. Yes, test the happy paths too, but test the parts that are not going to always be what you expect the user to do. One of my favorite stories is that when I built an application one time, it was very early in my career, I wrote an application that I thought was just rock solid. And do you know what the first person who used it did? They picked up their keyboard, they grabbed it, and they grabbed their fingers all the way across the keyboard, back and forth a few times. And my application broke. My heart was broken. I was like, oh, I never expected a user to do that. And my first thought was, well, what user is ever going to do that? Well, this user did. And the point here is you can't predict what's going to happen in your application. You don't know what people are going to test. And when somebody did that test with their fingers across the keyboard, obviously that's not a normal behavior, but the point was that you don't know what someone's going to be entering. So make sure you test those unhappy paths. And you put guard logic in there, and you create end-to-end tests to destroy your application. Then document it. You want to document the why. Why does it work the way it does? Why is this strange if statement in here? Why is this particular condition in this code? And then how should somebody be reading through this? How do they get started? How do they use this? And then, of course, online docs and code tours are a great way to document READMEs, change logs, code tours. Then demo. Self-documentation. You're going to create these anyway in some way, shape, or form. They don't have to be pretty. They don't have to be styled. They don't have to be beautiful. They just need to work. The demo's point is to show, how does that thing work? How does this one piece of code that you have work? And you could have more than one demo. I've written applications for UI libraries, for example, a calendar control, or a button, or a drop-down list, or an autocomplete. And I have different demos for each one of those. So I make sure that they work the right way. And they're all in the same repo, so I can test them all. Should highlight each of those features so I can automate those tests. It's just another form of visual documentation. And then we've got the review. So with the review, small PRs, multiple people in a review process, and of course, make sure that all of those can build and be previewed. So if you have something that you're putting together, maybe it's a website for documentation, make sure it builds and you can launch a preview site of it so people can look at it. If it's an actual running hands-on forms application, make sure it builds and launches in a preview environment so you can go test it with your automated testing or manual testing. So the review is absolutely essential. And then finally, we get to deploy, the 7th D. This one should, of course, happen at the end of the cycle, but could also be repeated or reverted when needed. So version strategy is absolutely critical. Preview URLs. Make sure when you deploy to a staging site of some kind so you can make sure that the new thing works as expected before replacing the old thing. That way there is no interruption of the users in case there is a problem. And of course, have communication channels for both ways, for you to communicate out and then back in. So let's talk about those channels with the 7 Ds. How do you create those communication channels? Well, they're really essential. And this may sound like common sense, but far too often we don't have them. You want to communicate with your users. One way to do this is to create a channel like on Slack or Teams, or send an email. But I'll tell you from experience, the best way to do it is have multiple forms of communication. Some people really gravitate towards certain tools. If you use, let's say, Slack inside your company, and that's the one way you talk, that's great. But I guarantee you that several people at your company don't use Slack all the time. That's not a surefire way to gather communication. If something's really important, you want to send it through your chat application, for example, Slack or Teams. You want to send an email on it. You may even want to have it if there's a newsletter or an update that people get. So there's different ways to communicate. Make sure that you communicate in all the ways if it's important, so everybody has an opportunity to learn about what's changing. Another thing you could do is you could set up a demo tour. When we had major releases at some of the companies I was at, we would literally go on a road show where we go out and we present what the new features are in a PowerPoint type presentation with an opportunity for people to ask questions so people can learn about what was the change and how does it affect their work. If you want people to know how to use something, you have to take the time to really educate them and get them up to speed at their pace. You've been working on something for 9 months for software. and you expect them to learn it and know it in 9 seconds, that's not always going to happen. So make sure you look at their pace, look at what they're learning, and make sure you provide channels for feedback because there's always going to be questions. Change logs are absolutely critical, especially for your end users and your developers. Your developers need to know what changed. They can go look at those places and people interacting with your software and code, especially if you write component libraries of any kind or packages. And of course, your users want to know, well, what's new in this release? So another thing you do is automate the change logs to be into some kind of a list or easily findable by your end users in your application, which is why it's important not just to link to the pull request, because that's often written developer speak, but also to put some kind of a very clear language that says this is what actually changed. I also recommend using pull requests and issue templates inside your GitHub repos because that will help you gather this information in a good, clean way. So what is this all for? Why do we do it? It's because we want to have a good return on investment. Anything we do, we put time into and energy. We want to make sure we're getting out the right things. And the 7Ds gives us return on investment. We get more efficient processes and code. We have less bugs in our code when we go release. We have consistent processes. And we also have expectations. We're setting up a contract between the developers, the technology team, and the end users, and of course our business stakeholders, that we are going to have these processes in place, and this is how it's going to work, including feedback channels. It's also about the confidence in the code to make sure that when we deploy, we feel highly confident these things are going to work. So we don't have that praying scenario that I started out with, where you write the code, you ship it, and then you pray that it works on a Friday night. I worked at an application once that had to go out live by Christmas, and we started on it in late November. And it was one of those frantic type of applications where we had to rewrite everything because there was a certain company rule where things were going away and we just learned about it and we had 4 weeks to get it out the door. Now, 4 weeks to write an application, and it wasn't massive, but it was still a very critical business application. Wasn't a lot of time, but we made sure we did all these things leading up to that. So when we deployed it, we created those communication channels. Luckily, most of the channels only had thank you, things are working great. But because we put all these things up front, it really helped out. Now, granted, this was a small application, but it will reduce considerably the amount of things that you have to fix after the fact. And that's really key because in a lot of companies, you don't have time after you deploy that's dedicated to maintain the application for too long, where you're constantly looking at it 24 hours a day, 7 days a week. You don't want to be doing that long term. Once you build up a large portfolio in your company for your applications, that becomes a huge maintenance issue. So you want your code to know that it has consistent expectations on how to run. And that's where your automated testing and your destroying really comes into play. So I mentioned a couple of tools. I want to show you 3 of them really quickly that can help you with the 7Ds. First is some kind of a CI/CD pipeline. I like to use Azure DevOps. Work for Microsoft, but honestly, I really like Azure DevOps quite a bit. It's a very robust, easy to use pipeline that you can create for your CI/CD process. So for example, here I have a Peacock extension and you can see how many times this has been run and passed versus failed or other cancellations that I might have had. It also checks all the tests that I have in my extension to make sure it works. They're all automated and it shows you how long it takes to do this. There's other tabs in here for showing you, okay, things worked great, but what environments do I put it in? Do I have a test environment? Do I have a staging environment? What are my release strategies? Do I want an automated release or some kind of a manual sign-off for my releases? You can set all these things up with any robust CI/CD tool, including something like Azure DevOps. You can also set up things like Azure Static Web Apps, which is a great tool for taking a website and deploying it all the way out to either a staging or a production environment. So with things like Azure Static Web Apps, you can just do something like create your code, push it to GitHub. And I mentioned earlier, when I push it to GitHub, does it always just get deployed? Well, with Static Web Apps, it can be. Or with Azure DevOps, it can be. You can set those up to, as soon as you get a pull request, everything gets kicked off, whether it's through GitHub Actions or through Azure DevOps or your own custom source control, that it then deploys your web app out to the web. And it gets it on CDNs everywhere. It gets you that global scale. And by the way, for the very simple or basic websites that I have out there, all of this has been free, which I really enjoy. And you can set up your static content and set up serverless functions. So using tools like this today, and there's others out there as well that you can use, these are really great for getting us all through that deployment side. Now, I mentioned documentation is really, really important. Well, there's a tool I really like called CodeTour. Everyone knows about README files and change logs in your GitHub repos, but what about code tours? Take a look at this. Inside VS Code, you might be looking at your code, and what you could do is you could actually record steps on certain lines. Here, the person's creating on line 32 a discussion about this is what this line is doing. So they're creating a code tour. You're saying, all right, this is the code I want to show up. So step 1 of 1 in the code tour, which will launch you through one step at a time, is to look at that line in that file. Now we're in a different file and creating a different step in the code tour. So you can see we have different steps. Once you save these, you can actually save the tours. And notice we've got tours in the bottom left called intro, status bar, and tree view. So we created that intro one, and when we press play, it'll actually walk the user line by line through different files of your code with explanations of what's happening. Why is this so cool? Because it shows them step by step how things are supposed to work. Have you ever opened up a GitHub repo and you're not sure where the code actually starts? There's hundreds of files, and you're like, where is like the entry point? Well, a code tour could help create that for your users where they start them at that point and walk them through. Or you could create a code tour that shows a specific feature. So you can create separate ones of these in your application. This is a free extension for VS Code, and it saves everything off to files for you in your repo. So it's just data files that get created for you. And it just is there for you, for your users to be able to actually create the code tour and run it. And with tools like vscode.dev, which was just announced this week, people can actually run VS Code in their browser without any installations and then use code tours to look at your repo. All they have to do, for example, in GitHub is hit the dot key and it opens up VS Code in the browser. And if they use code tours, you can have to give them that step. They can then walk through step by step through what the code looks like. It's a great way to explain what's happening to your users. So this was so popular at a company that I worked at called Disney that we actually created posters for it and put it around the office. And I have a picture of the poster up there. It was just very cool for us to do this at the time. Basically, we had the design, develop, destroy, document, demo, to review, and deploy steps in our poster. So it was fun for us. We all got behind it, and we managed to share these out with everybody. And as a recap, again, design, develop, destroy, document, demo, to review, and deploy. Which of the 7 Ds are you doing today? And which ones could you benefit from to make sure that you've got efficient code out there? What is your definition of done? For me, my definition of done is when all this is done and I deploy with confidence so I can turn off my computer and my phone and go home for the weekend and not worry about any problems. If I leave you with a final thought, it's that which can't be automated can't be relied upon. So a lot of this can be manual, and we want manual processes as well, but you want to automate as much as you absolutely can, like the code tours for your documentation. Automate your changelog creation. Make your issue templates more automated using those issue templates inside of GitHub repos. Make sure you're automating your end-to-end tests using tools like Playwright or your CI/CD with Azure DevOps, or the deployment of your apps to preview URLs and environments using things like Azure Static Web Apps. Automate as much as possible so you can focus on things which can't be automated. And here are some links for things that I showed you today. First, you can check out how to actually create a static web app yourself through this online tutorial, which is free. That's the first link. There's also documentation for creating those. And then there's also the free code tour extension, which you can grab from this link. And of course, some information on how to use Azure DevOps from the final. I want to thank you all for coming and think about this weekend. What's your definition of done? And with that, I'm done.